Alright, so if you've tried every method you can think of to solve a quadratic formula and you're struggling, factoring's not working, it's hard to take the square root, there is a way to find x-intercepts without factoring, taking the square root, or completing the square. And it's called the quadratic formula. You take all those numbers that are out in front of the x's and that last number c, and you plug it into this formula where it's the opposite of b plus n minus the square root of b squared minus 4ac, all of that over 2a. It's not just the square root over 2a, it's the whole thing. So where a, b, and c come from a quadratic equation in this form, so it needs to be in standard form. And although this formula looks big and scary, it's all numbers and it can be entered directly into your calculator. So for example, we've got 2x squared plus 4x minus 3. So a equals 2, b equals 4, and c equals negative 3. First thing we need to do is identify a, b, and c. So once we've done that, a is 2, b is 4, and c is negative 3. And then we know that our formula is opposite of b plus or minus square root b squared minus 4ac all over 2a. Okay? So there's two ways that you can do this. You could do it by hand, you could do it in your calculator. So in your calculator, you need to enter it into the calculator 2 times, once with the plus sign and then with a minus sign. That's really important. You're going to use the fraction feature to make it look exactly like it appears on the paper. So I'm going to plug in all my numbers. Now if you're going to do it by hand, that's fine. Just work what's under the radical first. So we're going to work the b squared minus 4ac part. So 4 squared minus 4 times 2 times negative 3. 4 squared is 16. 4 times 2 is 8 times 3 is 24. And since it's a negative and a negative, it makes it a positive. So you add those together and you get 40, and you just plug that back into the formula. And that looks a lot less scary than this does. Okay? From this, you can simplify out a 4. This can be 4 times 10. Square root of 4 is 2, so the 2 comes out. And you multiply your 2 times your 2 together, which is 4. And then at that point, you can simplify. 4 goes into negative 4, negative 1 times, plus or minus, and then the 2 over 4 would be 1/2, and you just leave your square root of 10 alone. Now, if you're plugging it into your calculator, you're going to use your fraction function. You're going to do negative 4, once with the plus, and then square root b squared minus 4 times a times c all over 2 times a. And when you plug that in, you get the square root of 10 minus 2 over 2. So it just simplified out the 2. It didn't break apart the fraction there. Okay? And then to get the other way, instead of typing it all in again, you go scroll back up and hit enter. And you're just going to go over to where you had that plus sign in front of the radical. And you're going to make that a minus sign. Be sure not to use a negative and to use a minus there. And you're going to hit enter again. And you get negative square root 10 minus 2 over 2, which is the exact same answer as this one. Okay? Where it just said 4 goes into 4. I get 2. They cancel. Oh, they made both of these 2's and canceled out that 2 completely. So it's the same thing. Okay, you got to keep in mind here that you could end up with negatives under the radical using that way, and this just means you need to remember to use complex numbers. You need to pull out an I. Okay, if you look at the quadratic formula, you can see that it has 2 working parts. All right. The opposite of b over 2a you've seen before. That's the formula we were using to find the axis of symmetry. The other part to it is this b squared minus 4ac. This part right here is called the discriminant. So if you're going back to this over here, let's take a look. If this number right here ends up positive, like it did in our formula, we ended up with 2 real solutions, okay? They're not pretty solutions, but it's real. I've got negative 1 plus half of square root of 10, or negative 1 minus half of square root of 10. Even though it just looks like 1, that is 2 real solutions. If this number ended up equaling 0, it would have gone away completely, and I would have ended up with exactly 1 solution. If this number were negative, that number right there ended up being negative, I would have had to pull out the letter I, and I'd end up with a complex answer. So we can use the discriminant to determine how many and what type of solutions there are. If this ends up being positive, I have 2 real solutions. If this ends up being negative, I have 2 imaginary solutions. And if this ends up equaling 0, I'll have exactly 1 real solution. Because there's only 3 types of, or 3 options for what type of number the discriminant is going to be. It's either going to be positive, negative, or equal 0. That's the only possibilities. So you can use the discriminant. It's very straightforward. You just plug in A, B, and C and see what you get. Alright, so no one cares about what the number's value is. If you're asked to find, and the way the question will be worded is, using the discriminant, find the number and type of solutions for this quadratic equation. So it doesn't matter what the number is. It could be 573, it could be 2. If it's positive, you get the correct answer is there are 2 real solutions. Okay? Same goes for if it's negative. I don't care how negative it is. It could be negative 0.6 or it could be negative 3,274,000. If it's negative, there are exactly 2 imaginary solutions. You have to pull that I out of the radical, making it 2 imaginary solutions. If it equals 0 and exactly 0, then there's 1 real solution because the radical goes away completely. So just some quick examples. How many and what type solutions do the following equations have? We're going to use b squared minus 4ac. I'm going to plug in the b, the 4, the a, and the c. So negative 3 squared is 9. 4 times 1 times 4 is 16. So 9 minus 16, it becomes negative 5. Again, nobody cares that that's a 5. It's that negative part that's really important. This means this particular one has 2 imaginary roots. For x squared minus 4x plus 4, when I plug in b, a, and c, I get 4 squared, negative 4 squared, which is 16, minus 4 times 1 times 4, which is 16. 16 minus 16 equals 0. This means there's exactly 1 real root. And last but not least, I've got x squared minus 5x plus 4, and I get negative 5 squared minus 4 times 1 times 4. So 25 minus 16, 25 minus 16 is 9. It's a positive number. That means there are 2 real roots.